we want to prove that if 2 to the power of n minus 1 is a prime number, then n is a prime number. And this is true for all natural numbers n. So in proving this statement, instead of directly proving this then this, it would actually be easier to prove the contrapositive of this statement. So if this statement would be written as if a then b, as written over here, then in this case 2 to the power of n minus 1 is prime is equal to a, and n is prime is equal to b, we can instead prove not b leads to not a, because this statement over here, not b leads to not a, is actually equivalent to a leads to b. So again, we can prove the contrapositive of this statement, and it'll actually be a lot easier than proving this statement directly. So how do we start? Well, in order to prove this, we have to first assume that, not b. In this case, not b would be that n isn't a prime number. So in that case, let's just say that n is equal to some a times some b. In this case, both a and b are positive integers. And in this case, since n has two factors over here, it is not prime. So n is definitely not prime, so n is not prime, or not b is definitely being held here. So let's plug n into 2 to the power of n minus 1 over here. So we can write 2 to the power of ab minus 1. Okay, and now with standard exponent rules, we can just rewrite this as 2 to the power of a, and then put that in parentheses, and then to the power of b minus 1. So what good does this do? Well, now we can rewrite this as 2 to the power of b minus 1 times 2 to the power of b times a minus 1 plus 2 to the power of b times a minus 2 times 2 to the power of b times a minus 3 all the way to 2 to the power of b, and then 2 to the power of 0, or just 1. Now, first of all, why is this expression equivalent to this expression? Well, let's just do a little bit of analysis on this expression so we can see why this is exactly the same as this. Well, if we multiply these out, obviously the 2b gets multiplied by each term and the minus 1 gets multiplied by each term. We're expecting it to equal this. And the reason for that is, well, let's multiply 2 to the power of b to 2 to the power of b times a minus 1. Well, b times a minus 1 can be written as ba minus b. So this is 2 to the power of b, and this is 2 to the power of ba minus b. These have the same base, so the exponents just add to each other. So you get b plus ba minus b. The b and the minus b cancel out, so you're just left with 2 to the power of ab, which is exactly what we have in this original expression right here. So that's good. But when we multiply 2 to the power of b to the second term right here in the second parentheses, you get 2 to the power of ab minus 2b when you multiply this out, and then you have this 2 to the power of b. Again, same base, but the b and the ab minus 2b get added together, so you're left with 2 to the power of ab minus b, which is not what we want. There is no 2 to the power of ab minus b over here, which is where this negative 1 comes in. This negative 1, when it gets multiplied by this previous term in the parentheses, negative 1 times 2 to the power of ba minus b, well, there's now a negative 2 to the power of ba minus b to counteract this positive 2 to the power of ba minus b, so they cancel out. And in fact, that's what happens with all these middle terms. There's a plus that term and then the minus that term. So that happens again and again. And let's see what happens when we get to these final terms. It's 2 to the power of b, 2 to the power of b, that's just 2 to the power of 2b, but then it gets counteracted by this minus 1 times the, and then originally before the 2 to the power of b, there was a 2 to the power of 2b, so there was a 2 to the power of 2b, and then a minus 2 to the power of 2b, those get canceled out. And finally, there's this plus 1 over here. 2 to the power of b times 1 is just 2 to the power of b, but then it gets canceled out by this minus 1 times 2 to the power of b, positive 2 to the power of b minus 2 to the power of b canceled out. And finally, this minus 1 times this plus 1 is just minus 1, which is where we get this minus 1 from this original expression. So this is definitely equivalent to this expression. But why did we write it like this in the first place? Well, that's because, keep in mind, we're saying that 2 to the power of a b minus 1 is not prime. Again, we're trying to prove not b leads to not a. So therefore, 2 to the power of ab minus 1 is not prime. And we have proved this because we've written 2 to the power of ab minus 1 as 2 terms, and you can't write a prime as 2 terms. So therefore, we concluded that 2 to the power of ab minus 1 is not prime. And finally, since we proved that if n is not prime, then 2 to the power of ab, or 2 to the power of n minus 1 is not prime, we have effectively proved that if 2 to the power of n minus 1 is prime, then n is prime. Again, because the contrapositive equals the original statement. Circle this. 2 to the power of n minus 1 is prime, then n is prime, and we are done.